Hello, this is Mike, KF5DEY, with the Cowtown Amateur Radio Club. This is going to be a demo of our remote radio system, at least as far as the Node-RED functionality goes. That includes rotor control and right now antenna switching and some status monitoring. Purpose of this video is for the club members to see how things work and how to do stuff. A couple things will change in the near future, but for now this is the way it's currently operating. At the end, there'll be, I should say at the end, I will talk through some of the code of Node-RED itself, so you can kind of see what does what, just for a basic Node-RED overview. I'm not a Node-RED programmer by any means, so there's probably a lot of errors involved. So for those of you interested in the coding part, stay till the end or skip to the end. For the club members to learn how to use the system, the first part's for you guys. So I already scheduled radio time, and it should be online pretty soon, and we'll know in a second. The way club members reach this page I'm going to show you is through a VPN. You have to be on the schedule. You have to have already had the VPN software installed and tested so you know it works. And after that point, if you're on the schedule, the VPN will allow you access to this page. The system has recognized the schedule and has started putting me on. Let's see if it's updated. Okay, so here's the Node-RED dashboard. Some of the stuff is still going to be off until the system is fully online, so I'm not going to flick any switches yet. But kind of general overview, some features. Obviously has an a name at the top and have a clock on the side, which may become useful. This code right here was copied and I've annotated in the notes. It works really well. It's a great circle map, or there's other terms for it. Essentially, here in Texas, right in the center, and we point in any direction, and that will signal the rotor to spin to that point. Our rotor is a tail twister attached to a Green Heron RT21, and I'm using the code that had already been generated. The slight difference is ours is on a network, so it took a little modification to access it. I'm just padding time a little bit till the radio comes on. As you can see, one of the features, so you click on the globe to get to spin. The heading right there is what the current heading is, and that's based on the program actually asking the rotor, okay, what heading are you on? We have some hot switches. These are general headings to those locations: due north, Europe, Africa, the Caribbean, South Pacific, New Zealand, I think. And actually, I don't remember what that one is. Hawaii. It's either New Zealand or Australia. Hawaii and Japan. And just kind of for clarification, or to explain how this works, we know Japan is over to the west of us, but on the globe it's right about here. If we're looking top down, if we're in the center, so that's why 320 brings you along this edge right to Japan and parts of China and Korea, etc. on your way over there. Just an example. So down below that, you have your hot buttons. Here you can stop anytime. If for whatever reason you want to stop what you're doing, or maybe you don't think it's responding correctly, you just hit stop and it'll send a command to stop the rotor within a few seconds. You can see below it's giving some status information. This tells you if our flex is online. It is not. It tells you if the 857 is online, and it is. For the flex, we're using the Smart SDR software. For the 857, we're using RC4B, written by the folks at Remote Hams. I think it's .org. So you can see right now the antenna is available. What that means, antenna switching is available. And our default is here with the flex is attached to the beam, 20-meter beam. And it's not showing it, but the 857 is on the off-center fed dipole. And as soon as I switch the antennas, it'll update it. This switch gives you rotor power control, so off means it's, or red means it's off. You push the button anywhere in here, and it turns green, and the rotor's on. And how do you know the rotor's on? The rotor will tell you where it's pointing right here. You'll see a little indication, and that's where it's pointing. So down below here we have the two switches. This will switch what radio or what antenna is attached to the flex radio, and it's either the beam or the off-center fed. And down below that, this will switch which other antenna, or I should say which radio is attached to the other antenna. So the other radio is the FT1000, and normally we only use that in the club. It is nearly impossible to use it remotely, so we just have it in the club. Besides, it's too nice to wear out with remote usage. But whatever the flex is on, this is on the opposite antenna. So you can kind of see how you swap it. And here's how you swap the antenna. There goes a slight delay. Don't have the flex on right now. If I did, you'd see this TX inhibit go on for about 10 seconds or so, then back off. Purpose of that is if, for whatever reason, this shouldn't happen, but if for whatever reason you're doing something, you're transmitting, you accidentally hit the antenna switch, it'll inhibit the flex transmission right then, switch the antenna, and then release it. If you're using digital modes and this happens, you've got it set for auto CQ or something, it will actually give you an error on the flex. It's not hurting anything, it's just going to tell you it's an error. You have to stop transmission on whatever digital mode you're using, wait a little bit, and if it doesn't come on, then flick the TX inhibit on, then back off again, and it'll clear it. The only time I've seen it happen is just when using the digital modes. When using the mic, the hand mic, it doesn't seem to do that. So you can see now that I put the flex on the opposite fed dipole, which puts the 857 on the beam. Now right now I've scheduled the 857, so that's the actually active radio. Our switching system turns on the appropriate radios. So right now the 857 is literally online. So this actually indicates that the server software itself is online, but the radio is online also. The flex schedule will turn the flex on itself, and you'll see that there. So this indicates that the flex radio is on. This actually indicates that the server for the 857 is on, but the 857 turns on with the server. So you can see down at the bottom, I can switch between the 857 and the FT1000 on the beam. So now, if someone's in the club, they could use the FT1000 there in person on the beam, or, give a second, on the dipole. There's built-in delays in the switches so that you just don't get too many clicks in and start switching around. Wherever radio is not on an antenna or any extra antenna ports are all plugged into dummy loads. So in no case is a radio not attached to at least a dummy load, and that's for radio protection. It's pretty self-critiquing. First off, you can't hardly talk to anybody, and the second one is it's so quiet, no static or anything. So now let me show you what the rotor power switch does. And a lot of this stuff is all tied together, so you have to have the radios online in order for the rotor power to turn on, which means, and the purpose of that is when the radios turn off, the rotors goes off. We don't need the rotor on if the antennas aren't on, or the radios aren't on. Though it'll send a stop command if it's mid sequence. It'll send a stop command to stop the rotor before it turns the power off, and that's to protect the rotor, make sure the brake's set without any damage. So right now you can see the rotor's on. It's pointing to the east, and I can click on the screen and point it somewhere else. So just for fun, I'll point here to due north, and roughly due north, but you'll see it's going to go through its motions the way the greenhorn's set up. It releases the brake. It actually goes opposite direction a little bit, make sure everything's released, and then spins towards your direction. There's a ramp up as it goes there, and then it decelerates back down as it approaches your heading. Nothing you have to do. I'm just explaining what it's actually doing. There is some lag in here, and I haven't figured out what causes it. It is just the connection through the networks and all that. So occasionally, it seems to stop. It appears to stop early, but you can see it's pretty close to where I clicked it, and It's good enough for government work. But you can see how they use the buttons now. If I just click Europe, it does the same thing. It puts an arc out there at Europe. Same thing, the rotor goes opposite direction for a second and then goes towards Europe. And again, sometimes it gives the impression it's not going to stop where it should. And occasionally you'll miss it by a few degrees here and there. You know, it's pretty good for remote use, right? Obviously, you're sitting right in front of it, it'll go exactly where you want it. So that's how the rotor works. And now if I turn the rotor off, you'll see a quick little message pops up, says rotor stopping, then powering off. And that's again to protect the rotor. Eventually this part down below will go into the scheduling system. But for now, until we get that built up, we have access here. One thing to note, if there are two radios showing on, then this is going to be locked out, the antenna power. So you can't switch antennas because we don't have a way, and we don't have an easy way to transmit and inhibit the 857. The only way we can at this point is to shut it off, and that's a little bit drastic. But it may be the future. So you can see on the next panel over here, it's got the current schedule, and this is showing who's on it right now. So you can see the 857, I'm sorry, the flex is off, and there's no one scheduled for it. 857 is on, and it's got me scheduled for it. The next hour, nobody's scheduled except me. And then 2 hours ahead, nobody's scheduled at all. This is all coming straight from our schedule, and it's updated within about a minute. So if you change the schedule on the main system, I'm sure I should say on our scheduling system, you'll see this update within a minute or so. We don't do any switching until about 3 minutes. There's some stuff it has to do, but you'll see if the schedule changed pretty much right away. And it's also a good clue for you if you're out there using it and you wonder, man, when did I schedule my time? Well, look, I'm scheduled through the next hour. So the current hour, next hour. And when's the hour? Well, there's your clock right there. So this is pretty much all you need to know to use the system. You can't, if the radios aren't online, you pretty much don't have access. Well, in backup. If you're not scheduled, you're not going to have access to this page. If the radios aren't online, you really don't have access to any of this stuff. It'll be off. The way this stuff works, these two switches, is there's a power goes to a relay, and each one of these is a different relay, which swaps the antennas around. So as long as they're powered on, they're on the opposite mode. This is the default powered off mode. So what that means is once these go offline, or the reason I bring this up is once these go offline, we don't need to have those switches powered on anymore. So they'll be turned off, and these are back to default to the beam and the up center fed. We want you to put what antenna you're putting in the schedule just for deconfliction. So if somebody else wants to use the other radio, they know what they're going to get. Eventually, like I said, in the scheduling system, it will preset this based on that. It will set the antennas based on what you have in the schedule. And if you don't put anything in there, this is the default is going to be. So if you don't request op center fed, you're going to be on the beam on the flex. The advantage of the beam is obviously you can spin it. The advantage of the op center fed is it goes down to 80 meters. So you have to choose which one you want. You can change mid-sequence. So half an hour in or whatever, you decide that, you know what, I want to use the beam instead. Just go into the schedule, and I'm talking about the future. Right now, you just switch it right there on the buttons. In the future, just go in the schedule, put it in there, and like I said, in about 3 minutes, it'll update, approximately, until we have maybe some future drastic change in how everything works. So I think that is about all you need to know. You don't have access to this page until you're on the schedule for that hour. That's the other part to mention. This is the current hour, so whoever has it for the current hour has access to this page, including if both radios are working, then both users have access to the page. So let's be professional out there. If you know somebody else is scheduled for it, you can talk to each other. We can't, it isn't set up where you can switch the antennas if both radios are online. Again, that's to protect it. But if you realize that you want something different, let one of the admins know, me or Mark, and we can swap it in another panel. And obviously, be nice on the rotor. If you're not scheduled for the beam, then don't go spin the rotor, that kind of thing. If you think you've got the right antenna scheduled or switched on, and you notice your SWR is bad at 80 meters, you've got the wrong antenna set. So some of this is on the user. I think it's pretty straightforward, fairly easy, I would assume. And if you want, you just click the appropriate area, and that should be good enough for most users on the beam. I think that's all I wanted to add here. If you guys have any questions, let me know, and I will get into detail. But remember, these are just indications. It's just showing you if they're locked or not. If there's no radios on, it's going to be locked. If both radios are on, it's going to be locked. So if one radio is on, it is unlocked, it's available, and you can switch away. Rotor power will always be available, again, if a radio is available. Sound good? This is just leaving what the last one was. It is off. So that ends the lesson part, or the user manual on how to use this page. The link is always going to be this first part. The last part may change depending on when you logged in, but this first part for us through our VPN will always be the correct address. And that will be in the notes you'll have access to. Okay, if you just wanted the lesson, that's it. The next part is going to be how it all works. So let me do this. So now we're in the meat of the thing. I'm just going to go through bit by bit. I copied a large chunk of this code from other code that's in the files in there. A few things I snagged off the open internet. Most of it is off the Node-RED ham radio groups IO. I'm going to start at the top. Here's the rotor control. And this, again, I've documented where this came from. But this is all straight copy. The only thing difference is this little bit right here. And you can see we had to use a TCP request node. And this is the local information for that node. And we're using the IP2SL serial to Ethernet adapter. So that's its IP address. It always uses port 999 for the serial connection. It just has the one port. And from then on, everything else works the same. It sends the same code. I just changed the other serial device. I think it had the USB or something in there. I just changed that to this. Well, the group of three of us finally figured out how to make it work. But we changed this over, and now it works perfectly. So we dropped that in. That's all the standard stuff. This is all copied straight. I tried to see if I could use a large image, and it just didn't work right. So I went back to the small image. I may reattempt that. This CSS just gives the correct button code for these buttons. And this clock template is, I don't know where I found it, but this, will obviously be in the code, but this puts the clock up in the header. So this portion is basically copied from the existing various RT21 flows. This little chunk I'm playing with, trying to get the page to refresh, but it's just not working right, so you can ignore that one. So next one down, this was in a different flow, and I think I annotated in the notes, but it gives you this indication, right? So this part of it just does a ping. So it's pinging the 857's computer, and it's pinging the 6500, and if it gets a ping, it turns the light green. If there's no ping, it turns the light red. Now, I used this to do all this safety stuff. So I'm checking if the rays are on or off. The way it does code is strange, so I had to have a separate one to look, see if they're both on, and give a true, they're both on, or they're both on false. There's probably a better way to do it, but this worked for me. Then I have another one just to see if A radio is on. If A radio is on, then it will allow the antenna switching. So we have a couple things in there that allow the gate to open. And let me skip over here. This gate blocks signals from going into the switch. And if you look at the web switch, we have the, was it KM Tronic web-based 8-port switch. This is from that code. This part and down here is from that code. So this simply gives, if it's on or off, it sends a different command to the address. What the gates do are, if they are closed, they don't allow any of these switches to pass through. So they get their code from these two things. Is a radio on? Are there two radios on or no radio on? So I think it's just set for, is there a radio on? Are the two radios on? If there's no radio on, I'm not worried about it because nobody's going to be scheduled for it and they're not going to switch it. Is kind of the general idea. So it checks, again, you can look at the code yourself. I had some of the stuff I did for buffering. Again, there's probably a better way to do it. But some code in there just to change the format a bit and to send the correct things to open and close these. It needs a gate command. So I was looking for a gate topic to move the data across. So this particular one, if false, this actually goes straight and just switches them off. So rather than waiting and doing the other switching mode, if both radios are off, boom, it shuts those off. This is the standard code for the Cowtown switch. The only unabused one is this one down here. This little bit is so that, well, initially just so you get a switch indication, a light switch or something. I can't remember what the original was, but I've made it where actually it moves the label around. So that's how you saw that the flex is on the beam or the flex is on the offset or fed, is this little bit of coding here changes the, I'm trying to think what it is, the message label. So change the message label, and this is reading the message label in the top. So it's pretty funny how it works. So that's how the flex radio one gets changed, and then the output of this one gets sent through, and that's now added into this for the message label for the other antenna. So it gives the other antenna name, and it gives the other radio in there. I'm kind of proud of that one. It's pretty fun. Like I said, I copied this bit of it. I just modified it so it used labels rather than just a light. This, for the rotor control power, you can see down here I'm getting information from, is the radio on? Right? So if a radio's on, then we'll let somebody use the rotor. If there isn't a radio on, then we'll power it off. It doesn't turn it on, it just tells it to power off. So again, it's using the same, this same code is just dumped right in there with some minor modifications. In fact, I probably need to put this delay in there. I think as I changed the code a couple times, I dropped it out of there. So this goes through, just looks for power off. That's all it cares about. Power on goes straight through. All right, so that's the power on switch. But to command a power off, it goes through here. It goes, want power off? Yes. Well, okay, then first we're going to do this. It's going to delay the shutdown. So this just simply slows down the command to shut down. And that triggers, right? If these two are on and off, this triggers on and off. This one puts a little thing up there saying it's shutting down, just so people know. And then this was just, where does that go? Oh, that sends a stop command. So that sends the stop command way up here, and stop on the RT21 is simply a semicolon. Nope, it's not in there. He actually put it in here, the code, but it's just a semicolon. Semicolon tells us stop. Pretty simple. I think I wrote this so it actually sends stop. Yeah, so it sends stop, so I just tie it to the original code. So, like I said, the on is normal, the off goes through a delay, it sends a stop command, it gives you a little message saying we're stopping the rotor first, and after about, I think it's 10 seconds, then it shuts off the rotor. Finally, the last little bit, I think it's the last little bit, nope, one more bit. This is the schedule part. So we have a file that's being generated by the a Raspberry Pi that actually is running the schedule and has all the switching on there for everything else. And eventually we'll have the switching for the antennas. It's generating a file just for this purpose with just all that information. And I was using it for a few things, and I've removed some of the things I was using on it. As you can see, I had some functions here I was using. But I'm definitely using the information for the schedule. I had it there, so might as well use it. And this just gives an indication the antennas are locked. And so originally I had it so this was how we did it, but occasionally the file wouldn't have information or the correct information, so it would fail this test, and then the antennas were locked or unlocked or switches non-switched. And I decided it made more sense just to have it on the power. So if the radios are powered on, that affects how that works. So that's just a display. So down here, this is copied from the FR Stack software. Pretty much exactly. You need this little bit just to get the... now, I could have done another way, but the code is already written. So I just copied this little bit so it gets the radio URL. And it creates that... let me back up a little bit. In this page, in this desktop dashboard, there's no other flows. It's just the one flow. On our admin page, we have the FR Stack flow running, in case we need to do something with that. But for here, we don't need it. The user doesn't need it. So I copied this from that because if it was already running, we'd just be able to get it easier. But I simply copied this code over. It gets the radio information. It pipes it into here. And this part I added. And I'm trying to think. I take it back. This is there. I believe what I added was a trigger. So this is the existing code in the FR Stack through here. I add the trigger so that if, here we go, here's the antenna switch, boom. You notice there's a 2-second delay before it actually switches. So if somebody hits the antenna switch, it sends a command here which triggers the TX inhibit. So it triggers it. It sends the, basically flicks the switch to inhibit for 10 seconds, and then it turns back off again and lets the switch back to normal. So that's how TX inhibit works. I think that is the existing code. A few other drops in there that I'm just kind of experimenting with, but it really works well. I was concerned about delays, that kind of thing. So it really worked on removing code. You can see I've got some notes in there. I was trying to do something else. It really worked on trying to remove code we didn't need and try to streamline it. And basic basic programming, logic programming of what do we want it to do? What are we trying to do? We want to protect the radio, so we don't want people switching if you don't know there's being switched. If both radios had TX inhibit, it wouldn't be a big deal. But because the Flex does, the 857 doesn't, we don't want to risk the potential of somebody transmitting and having the antenna switch mid-transmit. It's just not a good plan. Everything else is really set up so that if it's not in use, it's shut off. And that's why I said in the beginning that a lot of this will move to the scheduling hardware. And I won't have those switches in here anymore. But that's a few months down the road before that's going to be up and officially functioning. So I think that's about it. Hopefully that helps. If you look through the code, you'll notice I try to keep it in blocks. And I use the links quite a bit. I could have used more, I suppose, but at a certain point, no matter what you do, it's going to be confusing. But I try to keep it in chunks. So you see, I got the Cowtown web switcher. I've got this dashboard info. I've got the rotor function through here. Oh, here's a funny one. So this was part of that rotor code that I borrowed. And whatever reason, this won't show a heading. It shows brackets. It won't show the heading. So I had to put this in there. The format's incorrect. I just haven't changed it yet. So I mentioned this is the Cowtown stuff. This is stuff we wrote off a specific file. It's just a comma separated value, essentially a table with four across and however many files. But in our case, it's 2 lines per. So to make it easy, it has made 3 different files. So one's the current next hour and the 2 hours. So these are exactly the same code, just to parse that information. And this I got from the FR Stack stuff. Hope you enjoy. Thus ends the explanation of the code. I don't want to get any deeper than that, but if someone has specific questions, I'd be more willing to ask on the Groups IO forum. And for the club members that are still watching and wide awake, congratulations. Now you know, and I can see the mess behind the scenes. Well, part of it. You haven't seen Mark's Hardware. All right, thanks for listening. And this is for the Cowtown Amateur Radio Club Continuing Education Program.